Hi and welcome to this 3DExperience platform xShape walkthrough for a little rubber duck. Such a simple little bath toy found in most people's bathrooms, but modelling it in SOLIDWORKS could be a challenge. It has so many curves and organic shapes, especially looking at the duck's bill. So I decided I would move on to the 3DExperience platform and use the 3D Sculptor Rolls xShape app, which uses subdivision modelling, allowing me to push and pull shapes quickly. To create this duck, I used some images taken from the internet of a side, front and top view of a generic rubber duck to use as picture guides. The images are only going to be used to get the basic shape of the duck. Starting a new component, I began my model by sketching a guideline of 100mm and placing it midpoint to my axis. This helps me to control the overall height of my rubber duck and gives me a guide in which to resize my rubber duck images. To bring in the first image, I selected the ZX plane, the Tools tab, and the Insert Picture icon. I can browse and open the duck's side image and change the image transparency to around 45. This makes it easier to see all of the subdivision shape as I'm modelling it. Using the advanced settings, I'm able to flip the image horizontally and scale the image by a percentage, keeping it centered to my axes. I scaled the image down until the duck falls between the line. I can drag the image using the arrows to place it. I want the YZ plane to fall center to the neck of the duck. With that image added, I'm selecting the YZ plane and adding a new plane parallel to it, dragging it to line up at the start of the neck and bill. With this plane selected, I inserted the front duck view, and like the previous image, I changed the transparency and scaled it down. I lined up the image so that the bill matched up here, while still being in line along the bottom of the duck like this. Selecting the XY plane, I'm adding another plane to sit along this edge of the duck at the widest part of its body. Then with the new plane selected, I can add the top view image of the duck. This image needed rotating 90 degrees and scaling down to match the width of the duck using the side image as a guide. For the main duck body, I used the globe surface as the starting shape and snapped it onto my guide sketch. I switched on the symmetry tool along the ZX plane, that way I can edit the shape on one side and the duck will remain symmetric. A green line here shows me that the symmetry feature is active and along which line it is mirroring. Starting from the side view of the duck, I start moving the shape to begin modelling. The issue I have here is that my shape covers the image behind, so I need to make this transparent too using this icon here. Ignoring this top part of the duck as I'm keeping my duck's head round. When selecting and moving points from an XYZ position, I like to change the robot to move the points along the XYZ axes too. Now I can continue shaping the points of my surface to line up with the duck image. Again, the images are just a guide reference, not the exact end result I'm after. Once I shaped around the head profile, I could add more loops to the bottom of the shape to allow me to drag the shape down. I need more loops to give me more points and more control to create the bottom of the duck body. You could add more rows as you bring in the shape, but this can overcomplicate the shape before you've even started modelling, so I prefer to add new loops as I go along. Again, I'm following the outline of the duck with the point of the shape. For the tail, I extruded these faces to give me more geometry to work with. Then I added another loop to give me more control over the shape. I needed to ensure that the wireframe wasn't overlapping itself and that the green symmetry line was the part that followed the edge, like this. Viewing from the front of the duck, I could start to line up the points on this side too, adding in more loops when needed. You can see as I work on one side of the duck, the other side mirrors all of my movements. The image isn't exactly symmetric, so I'm only working on this side of the shape and focusing on this side of the duck image. The inner loops are also dragged to match the curvature of the outer loops, like this. Once I'm happy, I'll need to go back to the side view and move any points that have become out of place. Now to view from the top, the duck is very square. Again, I only need to move points from one side of the duck to reshape the profile. From this point, I need to switch up views to round off the duck's body and also to tweak the tail shape. The tail needed more loops to taper it further and make it easier to shape it. I can switch off the transparency to see the duck shape more clearly, then add some final mesh tweaks before knitting the surface. To create the bill of the duck, I used a quad ball. You may wonder as I select shapes why I choose a particular one. This is just from some experience modelling certain shapes. I've learnt what shapes work best for creating certain forms. I dropped the quad ball onto the guideline, which is centre to the duck. Pulling the shape out here, I changed the transparency to see the bill on my guide image. I squashed the entire surface down to encompass the whole shape of the bill on the image. Before continuing, I turn on the symmetry feature along the ZX plane. The bill is a little more finicky of a shape to model, but like the duck's body, I began with the side view and inserted more loops where needed. This loop was inserted to create the upper crease of the bill. A second loop was inserted to create the lower crease, which makes it easier to form the inner curve of the bill. Then I had to form the bottom of the bill to mould it onto the duck's face, adding a final loop here. With some tweaks, I could work on the front of the bill. Hiding the duck's body, I push and pull the points using the inner part of the robot like this to move points more freely. From the top view, I shaped the bill in reference to the photo, but not too closely that it would change the bill from other views. Again, the images are just guides. Turning off the transparency, I increase the mouth indent and smooth the contours on the top of the bill. After some final shape tweaks, I could knit the surface. A wing was modelled using the cone subdivision surface. I hid the duck's body to make it clearer to model. I shaped the wing around the duck's body and pushed it part way into the duck. The wing shape can be fairly simple in its design. Once done, I used the mirror feature. Once done, I could use the mirror feature with the ZX plane. With body selection checked, I could select the wing. I kept merge result checked as I wanted the bill body to remain separate. This makes it easier to colour the parts later on. Instead, I'm combining the wing bodies with the duck, using the combine feature. This allows me to add a small 5mm fillet around the edge of the wing, creating a more moulded appearance to the rubber duck. The next feature of the duck is the squeaker hole. For this element, I revolve cut a dome out of the base. I then cut a small hole into the duck by 2 mm from the geometry, selecting the dome face as the geometry and applying it. This hole allowed me to select its inner faces and shell the duck body by 1 mm. To finalise this feature of the duck, I revolved a lip profile around the opening of the hole, which some moulded rubber ducks have. I used the previous sketch as the axis for my revolve and merged the result. I used the previous sketch line as the axis for my revolve and merged the result. Hiding some of the planes and top view image of the duck, I could start modelling the eyes. Sketching onto the XY plane and viewing from the top, I had hidden the duck body to see the eye shape and location of the duck, but I needed this visible for a guide sketch to create a new plane. Sketching from the axis, I sketched a line past the edge of the duck's head, then added a perpendicular line midpoint to the end of my line to sit facing the duck's head where I want the eye to project from to split the duck's face. I added a new plane selecting the line and this point as a reference, so that the plane sits along my sketch guide. From here, I can sketch an ellipse near and in line with the eye from the image. I can't sketch on top of the eye as this would sit wrong, so I'm sketching to the right of the eye on a slight angle. I'm not worried about fully defining the sketch. I can just go to Features and Split Face. For the faces, I need to select all of the faces of the duck that the sketch needs to project onto, so I selected these four, and this sketch for my tool entities for the split, and then applied it. When I hover over the duck's face, you can see that the face has split to form the outline of the duck's eye. To see the eye more clearly, I can select the whole duck and apply a yellow appearance. Hiding the duck body, I can apply an orange to the duck's bill. And finally, selecting the faces of the eye, I can colour this white. This makes it easier for me to create a second sketch onto the new plane and sketch the pupil of the eye. This sketch could then also be split within the faces of the eye like this. I applied a black appearance to the pupil of the eye, selecting all of the split faces. To complete the rubber duck, I just mirrored over the eye features, selecting them from my Design Manager tree and applied it. Hiding all of my guide sketches and planes, my rubber duck is all finished and I could save it. I opened up the rubber duck in SOLIDWORKS and exported it into SOLIDWORKS Visualize to render. I also created this animation. I hope you enjoyed this tutorial. Thank you for watching.